Hi, my name is Stewart Lynch, and in this video I'm going to show you how you can create your own custom environment values. We'll learn the basics and then create our own environment value that will allow us to apply a different theme to our app based on a particular app purchase. I love getting your feedback, so tap the thumbs up button if you enjoyed this video and leave a comment below. Make sure you subscribe to the video and ring that bell to get notifications of new videos. And if you want to support my work, you can buy me a coffee. If you're wondering what environment values are, not the custom types, you might want to check out my video on that topic, and I'll leave a link in the description. I do have a starter project for this video, and I recommend that you download it and work along with me, so that in the end you'll have a completed project that you can refer to in the future if you want to implement custom environment values in your own projects. Bear with me and I'll go through the project code a little later, but I thought that at first I'd jump right into the topic, and then in the second part of the video we can create a more complicated custom environment value, and I'll step you through the code so that you'll understand what's going on. In the meantime, however, you don't need to understand how this project works for this first part. Let me start with a very quick example of Apple's built-in environment values and show you how you can implement them. An example of an environment value that your app knows about is the current color scheme, whether you're light mode or dark mode. So open sample project, and you'll see that I have a tint color that I've applied to this view, and it's red, and that's why the button and toolbar item is red. If we tap and go to the next view, because we're pushing it onto a navigation step, the tint color is applied here as well. Well, you can create a variable that is assigned the current color scheme by using the environment property wrapper and providing it with a key path for the environment value that you want to use. In our case, that's the color scheme key path, and we can assign it to a variable called color scheme. Well, we can use this knowledge then by changing our tint color based on the current color scheme. So, for example, using a ternary operator, if color scheme is dark, we'll set the tint to green. Otherwise, to red. Well, we can currently see that nothing's changed. But if I use the preview here, I can switch the preview to a dark mode. And notice that now the color has changed to green for our tint. Let me switch back. Well, some, but not all environment values will let you actually change that value, and an environment value applies to all the views in the hierarchy starting with that view down. The color scheme environment value is one of those, so we can set the color scheme for a particular view and all of its subviews. So for example, let's go to the second view and change the color scheme environment just for our group box. And we can do that by applying the environment modifier to the group box, and then we specify that key path, which is the color scheme, and then we can specify one of the color scheme's particular values, which can be dark. If I move my environment to the V stack, we see that now both are now in dark mode. Let me just move it back to the group box and leave it there. If you want to see what all of the current environment values are and their keys, check out Federico Zanatello's 5-star blog. It lists them all here and categorizes them. It's well worth the read. Let's change the tint in our first view back to red for the time being. And we're going to create our own custom environment keys and values and variables. And we're going to do that for this project that I've got here. Before we get into a more complex key that we might need, let's create a simple one first. And it's a 3-step process. So let's create a new folder called Environment Keys. Inside there, create a new file and call it App Color Key. Import SwiftUI and then create a struct with the same name and have it conform to the environment key protocol. You can let Xcode fix the problem for you, and it creates a type alias asking you to specify the type our keys value is going to represent. Well, this functions the same way that creating a UI view representable works. Before Xcode can suggest what properties or functions might be required, it needs to first know what type of object we're referring to. So in our case, we'll specify that our type alias for the value will be color. Well, now that Xcode knows this type, it can go further now and specify what properties and functions are required for the environment key protocol. And it turns out all it requires is a static property called default value. So let's specify that our default value will be the color red. And the type alias is no longer required because its only purpose was used to generate this first step. Now that we have a key, we can create an extension to the environment value struct. In here, we'll create a variable, and I like to call it the same as our key, but without the actual key ending. So in our case, appColor. And it will need to be defined as the type our key specifies, i.e. color. This is a computed property that requires a getter and a setter, namely the value we want to return when we ask for it, and the value we want to change it to if we're allowed to set it to something different. The Swift compiler automatically infers the associated value type as the type you specify for the default value. Then you use the key to define a new environment value property. So for the get, we simply retrieve the value for that key, which can be accessed as self, being the environment value of the type appColorKey.self. And then for the set, we simply assign that same content the new value. Now I said that there were 3 steps, but the third step is actually optional. And let me see what we can do with this new environment key without that third step right now. I'm going to return to the first view, and I'm going to remove the environment variable that we had for color scheme. I'm going to add a new environment variable, and notice that our key is recognized in its appColor, and I'm going to assign it to a new variable called appColor. Now the default value for there is red, so if I apply this to our tint, being tint using the appColor, which is a color, you'll see that the button's red because we defined a default color of red for our appColor key value. Let's see how we can take advantage of our new key. Then, when we present our first view, we can change our environment key by assigning a new value. So this will get injected basically into that first view, and if we specify that appColor to be green. Now we'll see that in the preview nothing's changed because it has no knowledge of that app entry point. But let's run this in the app simulator now. As you can see, the tint color of our button in the first view is now green. That environment value is applied to and accessible from the view. Well, this way of changing the value for this appColor key is fine, but you'll often see it done differently, and that's the third optional step that I referred to. So return to the environment key file and create an extension to view so that we can apply a new value to the view by way of a function using the same name as our key that accepts our environment key type and returns some modified view. That modification is done by assigning the color to the environment key here, just as we did in our view specifically. We don't need the period in front of the environment because we are using a function of the view type itself. Let's see how we can apply this now. So returning to the app starting point, we can specify the app color being green right here. If I run this app in the simulator once more, we see that the button has a green tint. Well, that's the basics, but it doesn't really show you the power of custom environment values. If you're still interested, stick with me as we're going to take this to the next level. But first, let me comment out that app color modifier here, as we're not going to be using it. So let's move on. But before we do that, let me take you through the app. If you sorted it all out now, you can use the link in the description to jump to the next section where we create the app purchase model. This application simulates an in-app purchase. It checks simulating to see if a purchase has been made. And the way I simulate this is to create an observable object called App Store Service. In this model, I create a URL for a file that I call receipt, and it's a text file that resides in the Documents directory. And when the service is initialized, I call the retrieve purchase function to check to see if that file exists at that file path. And then I check to see what is the content of that file. There should only ever be one of two different strings, either premium or premium plus. And these are two of the raw values for a receipt enum that I've created. Well, if that file isn't found, or if the string is not one of those two cases, I delete the file and assign the free case to a published receipt variable. The makePurchase function will receive a new case for our purchase type and save that to the receipt URL location, overwriting any one that might already be there. And there's one more Boolean property called makePurchase that is initially set to false, and I use this property to display the purchase screen when it's set to true, and you'll see that shortly. In the app entry, you see I've created an instance of our App Store service as a state object, and I inject it into the environment so either the purchase view or the first view will be able to use it. If the App Store makePurchase property is true, then the purchase view is displayed. Otherwise, the first view. So by default, since we initialized the App Store service on launch, this value is set to false, so we'll be showing our first view first. Well, in that first view, there is a toolbar button that will set this value to true. So this will force the app to reload and display the purchase view. I also have a text view that currently displays the receipt's raw value as part of the text in the view. And I have a custom view modifier called WithBackground that I use to change the background of our view. And this is a simple view modifier that simply embeds the content within a Z-stack and then sets the first or background to a rectangle filled with a color gradient at an opacity of 0.3. and then expands to ignore all safe areas, filling the entire background. This means then back in the first view, we can take any content like the entire contents of this body in a view and apply this view modifier as I've done this for the first view. I've also done it in the second view. And also again in the purchase view. And the purchase view has a number of buttons and text in a group box that describes what features you get if you make an in-app purchase. When you tap on one of the buttons, it calls the makePurchase function that will accept the receipt type for that particular button and that particular type of purchase. And this will toggle a Boolean site property that's called Purchase in Progress that will display simply a progress view over the entire VStack and disable the underlying view to kind of represent a call to the App Store. If the receipt is not nil, it calls the App Store Services class makePurchase function to update the receipt file and then waits for 3 seconds to simulate that purchase and then toggles back the in-progress Boolean to dismiss the progress view. If the receipt was nil, we'll call the clearPurchase function in the App Store Service class that will delete the file and set the receipt to free. Our app will offer different features based on the purchase, but I want to update the UI so it's obvious what purchase level we're at. And you could use the same technique in a game if you're moving to different levels. Let me show you how that works when I run in the simulator. If I launch the app, I get to that first view. I can tap on the toolbar button to get to the purchase screen. And if I tap on Premium, the progress bar spins for 3 seconds, and then I'm taken back to the first view where the text view indicates that I'm now Premium. Returning to the purchase view, I see the Premium button is disabled because I'm on that purchase. If I stop and then restart the app, it shows that that purchase has persisted. Similarly, I can upgrade to Premium Plus, and if I return back, both purchases options are disabled, but I can revoke all purchases and I'm back at the free level. Up until now, we've used a single value for our environment value. That was the color. But you're not restricted to a single type. You can use an object of your choice. For example, let's say that based on our purchase receipt type, I want to display a different theme for my interface. So I'm going to create a new file, and I'll call it app purchase theme. Inside there, I'm going to import UI because I want to use color. And then I'm going to create a struct of the same name, app purchase theme, and I'm going to create 3 different properties. The first will be a string for the name. The second will be a color called primary. And the third, another color called secondary. Next, I'm going to create a static function called theme that will have a single parameter called receipt that is a receipt type and return an instance of our app purchase theme. Well, we can switch on that receipt and it creates our 3 different cases. So for free, we're going to return an app purchase theme. And for the name, I'll use free version. For the primary color, I'll set it to red. And for the secondary color, I'll specify orange. Well, let me just copy and paste this return for the next 2 cases. So for premium, we can specify the name of premium version. And for the colors, I'm going to choose blue and green. And then for premium plus, the name will be premium plus version. And I'll use the colors purple and indigo. So let's create our environment key with this type. So in the environment keys folder, we'll create a new file, and I'm going to call it app theme key. Here's the 3-step process. We'll create a struct called app theme key and have it conform to the environment key protocol. Or we could let Xcode generate that type alias stub for us and then the static default value property, but this is simple enough to remember, so I can just start right from there. We'll need that static variable named default value, and we specify that our type is the app purchase theme. Well, what do we want for the default value? Well, we want the free type, so we can use that static function that we created in our app purchase theme to create the theme for that free case. Step 2 is to create the extension for the environment values. I'll create a computed property called app theme that is of type app purchase theme. This will require a getter and a setter. The get is for self for the app theme type key. And then I just copy this, and then the setter will use that value and assign to it the new value. And then that third optional step is to create the extension for view, where I create a function using the same name as my variable that will accept a theme, which is an app purchase theme, and then return some view. And it's here where I actually assign to the environment at that key path app theme, whatever theme had been passed in to the function. So I can apply that app theme to the environment for the entire group at the app entry point. And since that app theme view modifier function requires that app purchase theme, we can use that static function once more to fetch the theme for the receipt that we get from the App Store service receipt. Now that we have that, we can use our 3 theme properties. In the first view then, let's remove that old app color environment variable, and we're going to replace it with one for the app theme environment key. And it's recognized because we've already defined it, and we'll assign it to a variable of the same name, app theme. In our text view then, rather than using the raw value, I'm going to use the app theme name. where I set the background, I'm going to change the color here to be the app theme's secondary color. And then the tint, we'll use the app theme primary. We'll repeat this process for our other two views. In the second view, we'll get the environment variable for the app theme key path and again assign it to app theme. And then where we set the background, again, we'll apply the app theme's secondary color. And then in the purchase view, again, we'll need the environment value for app theme. And then we make the two changes for the background to be the app theme secondary. And this time we'll set the tint to the app theme primary. Let's run our app. On the first run, we see that we are at the free version because we have revoked our purchase after the last test. Notice as I go to the next view, the theme is carried through. Perfect. Similarly, if I go to the purchase view, well, let's make a premium purchase. Notice the theme changing and we return to the first view after those 3 seconds, and that carries through here too. Let's go to a Premium Plus purchase. This looks good too. If we stop and run the app once more, we'll see that that theme has persisted and it's still applied. If I go back now and revoke my purchase, we're back at that red free level. And then stopping and starting again, the app verifies that once again. Perfect. Well, I hope you've learned something in this video that you'll be able to apply to your own projects, whether that be for theming or getting your users additional privileges or a host of other ideas that you may come up with. If you enjoyed this video, please give it a thumbs up and leave a comment. Make sure you subscribe to my channel and get notified of new videos as they are released. Thanks for watching.